Alright, so we're verifying trig identities, second day. I pulled this out of your book, page 899. So here's some suggestions about verifying identities. So you've seen me do this, this one right here, where we want to write in sine and cosine. Right? You saw me do that one. I've talked about you're just doing trig. You're just doing some basic algebra, so factoring or multiplying. All right. Um, you've seen me do this. You've done it yourself. Substitute one or the trig functions. You're trying to simplify. You're trying to make it smaller. And then the properties of equality do not apply. So this very last one, all right? Well, blue is probably not the best, but the properties of equality. So that means when you can't do something to both sides. So like if I gave you 2x is equal to 5, all right, or 2 tangent of x is equal to 5. I'm just making things up. You cannot divide both sides by 2, all right? So that's all that's saying is we cannot we cannot do one, to both sides. All right, so it's page 899. I don't know if you want to write it in your notes. Do you want to, what you're going to do with this? But it's there for you to look back at. All right. So let's get this out of the way. And here I go again, moving stuff around. Now we're looking at these trig identities. Alright, sorry guys. So we're looking at these trig identities. I'm hoping by now you're comfortable with these things. These two right here, you should know. These we've been doing for weeks. These right here are new. Alright, those are the new ones. I'm not telling you have to memorize them, but be able to manipulate them. Alright, you're going to have to be able to, let's say, take this one right here and say, oh, I know that tangent squared of theta is equal to secant squared of theta minus 1, because all you did was subtract 1 from both sides. Alright, you have to be able to manipulate it. And then, so it's all basic algebra. And you guys are very good at algebra. You just have to be able to look at these things. So today, I want to take a look at these down here. Alright? These are the ones that I'm going to be looking at down there. They come into play, but they're not very common. Alright, so let's start looking at some problems. Now, I want you guys trying these on your own. I'm going to do them, but I do want you to hit pause and give it a try. So example 1. I'm telling you sine of x times cosine of x equals 1. Give it a try, please. I'm starting off real easy, and then I'm trying to go more and more difficult. Right? You give it a try. Alright, now let's go through it together. Sine of x, I'm going to leave alone. But I'm going to take cosine of x and rewrite it. Sine of x, well, we look at cosine of x. Cosecant. Cosecant is simply 1 over sine. 1 over sine of x. And I'm trying to prove that this all equals 1. We agree that I can put that over 1. And then we're cross canceling. Basic algebra. 1 equals 1. So that one's good. Let's look at another example. If I gave you cosine of pi over 2 minus theta plus 1, all of this divided by 1 minus sine of negative theta, I want to prove that that all equals 1. So again, here we go. Here's the shifting. So these cofunction identities, we've seen those as we're just shifting. So cosine, cosine, there it is. So cosine of pi over 2 minus theta is simply equal to sine of x, or we're using theta, sine of theta plus 1 over 1 minus. Now I'm looking at this negative right there. Sine of negative theta. Sine of negative theta. All we're doing is we take that negative and, we take this negative and we shift it out into the front. Alright, so I'm taking this negative and I'm going to move it out in front. So minus sine of theta. Two negatives give me a positive. I have sine of theta plus 1 over 1 plus sine of theta. Well, does it matter if I have 2 plus 3 or 3 plus 2? They both give me 5. Same thing here. Exactly the same type of problem. I have sine of theta plus 1. I'm going to take that and just switch it around so that I have sine of theta plus 1. And again, remember, I'm trying to prove that this equals 1. Sine of theta plus 1 over sine of theta plus 1. 1 equals 1. I hope you guys are realizing that this is basic algebra that we're using with trig functions. Alright, I hope you guys are noticing that. Part C. Cosecant squared of theta minus cotangent squared of theta all over 1 minus sine squared of theta. I want to prove that this equals secant squared of theta. Again, hit pause. You try it. Alright. Hopefully you gave this a try. So I'm looking at cosecant squared minus cotangent squared. And I look down here and I'm seeing that. Alright, I see cotangent squared theta plus 1. I hope you guys can realize that if I subtract cotangent squared of theta from both sides, I end up with 1 equals cosecant squared of theta minus cotangent squared of theta. We're doing basic algebra. Exactly the same, yes? Alright, so I'm replacing all of that with 1 over. Now I'm looking at 1 minus sine squared of theta. 1 minus sine squared of theta. Okay, we do something there. I'm sorry, again, there I go with the blue on the blue. But can I do something there? Do you agree if I subtract sine squared, I end up with 1 minus sine squared of theta is equal to cosine squared of theta. Alright, well, then I'm going to take and just replace that with cosine squared of theta. So I did 2 transformations in one step. Last but not least, 1 over cosine is just equal to secant. Well, since it's squared, it's just going to be, oops, not cosecant, sorry. It's just going to be secant squared of theta is equal to exactly what we were trying to prove, secant squared of theta. So these problems are not as difficult as you think they are. You just have to manipulate. You have to be comfortable manipulating. Right? And again, basic algebra, which I know you guys can do. Some of you guys just need a little more confidence in yourselves. Alright, last problem. Here, giving you guys a tough one. Again, I want you to give it a try. You get stuck, that's okay. But give it a good, honest attempt. Don't give up right away. So it's a nice ugly one. And I want you to prove that this is equal to 2 cosecant of x. Alright? I want you proving. Sorry. I want you proving that. And the thing I want you to know, I want you to start off with is get those fractions added. Okay, let's start going through this now. So I want to combine these fractions together. So that means I need a common denominator. Well, do you remember in the past when we were doing these problems? All over sine of x, and you recall that all I did was I extended the fraction bar, and I kept saying, what does this denominator have that this one does not? And the answer is 1 plus cosine of x. What I do to the denominator, I have to do to the numerator. Plus alright, so what I do, over here I have sine of x, 1 plus cosine of x, and again, what does this denominator have that this one does not? And the answer is sine of x. So what I do to the denominator, I have to do to the numerator. Alright, and I'm still trying to get it to equal cosecant, 2 cosecant of x. Alright, now we have the same denominator, so I'm just going to write one big old fraction bar. Sine of x times 1 plus cosine of x. Now I could start thinking about distributing, but I don't know if that's going to help me or not, so I'm going to hold off. I don't want to do a bunch of extra work for nothing, so I'm just going to hold off. Up here, I have a binomial times a binomial. So, double distributive property, FOIL, whatever you want to call it. Alright, I'm just going to do it quick. You guys should be comfortable with this. I have 1 plus 2 cosine of x plus cosine squared of x. So that takes care of the left fraction. Plus, now I'm looking at that part. Sine x times sine of x is merely sine squared of x. Is there anything over here that you're noticing that will help us? So I start looking at these trig functions. And I notice cosine squared plus sine squared equals 1. Well, I have cosine squared plus sine squared. So all of this mess right here is just equal to 1. Alright, so I'm going to rewrite 1 plus 2 cosine of x plus 1 all over sine of x times 1 plus cosine of x. Right? Keep it in mind, I'm trying to make this equal to 2 times the cosecant of x. I hope you're following along. Now, some simple 1 plus 1, 2 plus 2 times the cosine of x all over sine of x times 1 plus cosine of x. Now I'm looking at this thing. I see a 2 there. I see a 2 there. I said, well, what's going to happen if I factor? What would happen if I factor out that 2? So let's factor out that 2. There's that 2. What am I left with? 1 plus cosine of x all over sine of x times 1 plus cosine of x. Those cancel on us. So we're simplifying this thing. It's getting less and less. It's an ugly problem, but it's getting less and less. So then I'm left with 2 times, now I'm just going to rewrite this just so that it stands out a little bit more. And then let's drag this back down so we can take a look at it. 1 over sine is equal to cosecant. So I have 2 times the cosecant of x. And I believe, there we go, that's exactly what we wanted. 2 cosecant of x.